Welcome to another video in the Learn APL with Neural Networks series. In this video what we will do is we will take a look at the images from the MNIST dataset, or from the data. We will take a look at the data and try to display them, display the data, display the rows of the CSV as images that we can take a look at. And so in order to do that, we will start off by, whoops, I have no idea how I did that. We'll start off by actually defining the path where your data is. So let me copy that path and let me paste it in here. So this is the path of the files. Let's add the trailing slash there. Now let me read some data. And we do that with quad CSV, and now I don't need the whole thing. So let me just use the variant to read a single row, because I don't care about the other rows for now. I just want to experiment. And let's read it from the path. And let's open this one of the files. It doesn't matter that much. Now what's the shape of the data? It's a matrix, so let me make it a vector, just for convenience. Now the shape of the data. Okay, so it's a vector now. Now what are all of these elements? So let me show you the values here. So what are all of these? Actually, are these integers? Yeah, they're not. These are strings. So there's something important that we have to do here, which is tell CSV, quad CSV, that we want to read integers. So these are integers, yeah, and we know that beforehand, so we can be very explicit about it. And so the right argument to quad CSV, it can be just the path, but it can be, you can give more information to quad CSV. So the thing that you give after the path is the encoding, and you can give it an empty encoding so that it guesses, so you don't have to worry about that. And then you can give it an integer, one of a specific set of options that you can find in the documentation. And those options will tell quad CSV how to read the columns. And so you can specify a single code for each column. So you can have different columns, right? You can have dates, integers, text, etc. But I know that the whole thing is integers, and I know there's no integer missing, or there should be no integer missing. So if I give it a 2, what quad CSV will try to do is read all of the columns as integers, and it will fail with an error if some column doesn't look like an integer. So we do the whole thing again, and now we can take a look at the data. And these are integers. I can now sum them, for example. Okay, so what is this? So these things are supposed to be those MNIST digits, right? And I have them in here. But the data that we downloaded, the data that we downloaded is a CSV with thousands of rows. So what's actually going on? Well, each digit here, each image, was written as a vector. So this is a matrix of pixels, right? And what they did was they reveled it. They reveled each image, the pixels of each image, and they store them as rows. So each row represents one of the drawings. And if you take a look at the number of elements in here, you see that there's 785. Why is that? Because the first one tells you what digit is being represented. So the only row that I read, I should actually maybe call this image. So this is the image, this represents the image of a 7. And then the remaining 784 are the pixels of a 28 by 28 image. So an image that is 28 by 28 has 784 pixels, which corresponds to everything else from the image apart from the very first number. And then the values that are in here, so let's take a look at the unique values inside the image. These numbers, these are numbers from 0 to 255. So the images are in grayscale. Okay. Now what we can do is we can use bracket indexing to take a look at this. How are we going to do that? Let's do the following. Let's do an empty space and a I never know how this is called in English, so let me call it a hashtag. So the empty space and the hashtag. Now what we can do is, can I please find out where the pixel of an image is not blank? And now can I do the whole thing as the 28 by 28 image that this actually is? And now if I press enter, this is what I get. Now I was taking a look at that thing over there, but that's because I forgot to drop the first digits in the image. And so this is what we get. Yeah, so this is clearly a 7. Now what I can do is, instead of reading just one image, I can read some data, and let's read maybe 10 of these. And now, so what can I do? Well, instead of reading, so I can read the first row of the data, and then I can flatten it. So yeah, this reads the first row of the data and flattens it, except I did something clearly wrong. And what might that be? What did I do wrong? Let me first take the... I'm doing something clearly wrong, so let me take a Oh, because I was flattening the data. Yeah, I don't want to flatten the data anymore because now I'm reading the rows. Sorry about that. So yeah, let me read 10 rows. And now we're going to take a look at the 7. Or we can take a look at the next one. Or the next one. Or the next one. Now I'm just taking a look at some different rows. Now this is a terrible way of picking rows. So what we can actually do is do data and then also use bracket indexing, and now we can access a single row like that, and we add the semicolon there because we don't want to specify the column. So in here I would type the indices of the columns, but I want to pick all of the columns, so the only thing I need to do is change the first value before the semicolon. We can see here, so this gives me a full row. This gives me the first 10 columns of the first row of row 1. Yep. And this gives me the first 10 columns of the whole data across all the rows. So that's what's happening. Okay, so this is how we are going to visualize our digits, and in the next video we will just write this into a... Actually, we can do it right now, yeah? So we just take this expression and we define it as a simple function so that we have it for later. So let's edit my draw MNIST digit. Let's just say draw digit, it's shorter. And now that's what it will do is essentially this. So it will index into that after reshaping, and it has to drop the digit as well, and it just finds out where it is greater than 0. So we can fix this, and now we can do something like draw digits of the image, or we can read different rows from the data. So the first row, now this is not going to work. Oh, it did work, that's nice, okay. So we can just give it different rows and it just keeps on drawing them. So we can close this, and this is just a nice little helper function for our for the work we are doing. And we added it to the things that we have already done. So this is done. I'll see you in the next video where we start building the network to actually learn how to recognize these digits. See you in the next one, and bye.